Hey guys, so I decided to make myself a test review book. And I would encourage you to do what you think will be best for you to solidify some of these topics and concepts. There's a lot that's going to be in the unit test. Just want to give you a little preview right here, okay, on my book. So again, at any time you can pause and write information down. If you want to make a book like this, I encourage you to do so and put a little color into it. You can do it how I have structured it or any other way. But when you write things down and distill information in your own words, that's when you'll retain it the most. So here is what I'd like you to know. So there are going to be 25 questions on the unit test. It's all going to be quadratics. So it's going to be basically Jim and Pam. There are going to be 6 questions about the basics and axis of symmetry and what the shape of a graph is, etc. Then you're going to have 3 questions about graphing. I'm going to turn this off, see if that's better. Maybe that's better. That looks better. There'll be 3 questions on graphing. I'm not going to have you graph because it would just be too hard on a Google form test like that, but it would be identifying things like domain and range and which graph matches the equation. There are going to be 3 questions about transformations and then the vertex form. There are going to be 7 questions about solving. So that's going to be all of those types of solving like factoring, square roots, complete the square, okay? There are going to be lots of trinomials in there to solve. And don't forget, once you get your factors, you can think ahead that the solutions are going to be the opposite sign of the factors. There's going to be one kind of bigger question on the quadratic formula, and to have you look at a quadratic equation. It might be a trinomial, for example, to then plug into that formula and try to solve and simplify radicals, etc. And then there are going to be 5 word problems. So word problems are going to be a consecutive integer problem, a geometric application like find the area, projectile motion, and quadratic regression. And also like maximum height, like we call it falling object types of questions, okay? So hopefully that helps to wrap your head around how to prepare. Now, if I zoom back out, show you the rest of this. Okay, so what I did here is I literally took some copy paper that we have and I looked through all of my notes, from 1 to 15, and I started compiling them. So again, you can pause if you find that this might help you, then I encourage you to do it. So here's my cheat sheet. You can pause it and write stuff down if you want. I feel like I need to make this a little bigger. Hold on. Oh, it's okay. So here's my cheat sheet. So I have some terms that I really need to know for, and also if you make a little booklet for yourself, keep it because it's going to be a good study guide even for your SATs. I put here like what a quadratic term is. So it has to have a second power, nothing like a third power or a linear term. I put the parent function here, standard form, ax squared plus bx plus c, axis of symmetry, what it is, and also what that formula is. X equals negative b over 2a, which will, for any quadratic equation, you can determine what x is from this quick formula and then find your vertex. The vertex is the turning point of the parabola. You have a maximum or minimum here. Here's the vertex form, which tells me very quickly what the vertex is, which is HK, right? It also tells me how it transforms. So down here, I listed all the transformations. So transformations are basically how a graph changes from the parent, which is y equals x squared. If I see a negative a, I know it's going to flip. It's going to go down, reflect down. A dilation, if I go back to my a value here, if I have a big A that's over 1, it's going to be stretched and thin. If it's a fraction, like maybe a is instead maybe a half, then I'm going to have compressed and fat. Right. Translation is SL, right, in that word. Translation in geometric transformations will always mean a slide, or how something moves up and down, vertically. Maybe someday you'll even learn diagonally. But for now, we're doing a horizontal. H up here tells us if a parabola moves left or right. And remember, it's counterintuitive, so if you have a negative h, it's going to move to the right. Positive h moves to the left. And then k is just as it looks like. So k is going to move, if it's a positive k, it's going to move up. Negative k moves down. The solutions are also called zeros, like when the y is 0, or where it meets the x's, or the roots. Here are the methods to solve. So you have 5 methods, which you should be studying. Maybe this will help. You have factoring. And remember, whenever you're trying to solve a quadratic, you're trying to find when y is 0, right? So that's why we set equations to equal to 0. And then we factor them. We try to figure out what are the 2 factors, maybe 3 factors, that when you multiply them together, I might get a 0 as our answer. So that's why we learn to factor them out. So we can do greatest common factor, difference of squares, trinomials. We can do complete the square. And that's if I have, like, b is even, I can set it up like this. And I can divide. There's all those things like divide by, split the b in half, square it, add that square number to both sides. You're basically completing or creating a square trinomial. If you see that you have 2 values that might be square numbers, you could just take the square roots from both sides. You could obviously graph, find the vertex and plug in values in a table. And you could do the quadratic formula, which is this formula, and then you basically just plug and play. So here's my cheat sheet that I would probably use for my test. Okay, so graphing on the right side, here's the next topic, it's graphing. And I've gone over it several times, but what you want to do, here are the steps, is you want to find your x first of an equation. By plugging in the values, you want to use that axis of symmetry formula, that x equals negative b over 2a. It's very helpful. Plug in, once you get your x, you want to plug it back into the original equation to get your y value. That's your vertex. You're going to graph that vertex, and then you're going to create this table of values, which I did down here. So here's my example. I came up with my own examples. So y equals x squared plus 4x minus 5. I identified my a and my b. Again, I got my x. I plugged my x value back in to get my y. I went ahead and graphed it. Here's my sketch. Found my domain is always the real numbers going in. The range is what my y's could be. And if I look quickly at this, I know that the y values can't be below this negative 9 value. So it's always tied to your y in the vertex. The zeros are my solutions. So it's where they meet the x-axis. And again, here's my work. Here's my table. If you look at the table, you can see very quickly that here's my vertex, right? And you can see on both sides, right, that mirror image that will tell me that it's a quadratic. Okay, next. So now I have transformations in vertex form. So again, I think I went over it, but we can do it again. So here we have that vertex form. Again, we like it because it tells us the vertex, how it moves. Opposite HK, that's going to be the vertex. Let's see, whatever that H is going to be the axis of symmetry. And the dilation is how it stretches or compresses. So it's, again, it's based on the A value based on this, if it's greater than 1 or a fraction, like between 0 and 1. The reflection is the flip, so that just depends on the sign of A, right? If it's going to be positive or negative, it's going to flip up or flip down. Translation is based on the H. Remember, H, negative H goes right, positive H goes left. Vertical slide is based on K. You're going to be asked how a function moves or transforms from the parent function, which should be etched into your brain, y equals x squared. Here are some examples of transformations. So these are mostly in vertex form. think to yourself, are all of them actually in vertex form, or which ones are maybe not in vertex form? Okay. Hopefully you said that C and E are not in vertex form, right? There's no parentheses. My x squared is right here. I have negative 2x squared here. So let's just review them quickly. So I see that h value is positive 4, so I'm going to go left 4, and I'm going to go down 2. See, it's good that I'm going over this. Down 2, because I have this value. Okay, I even sketched out the graph. So here I have a negative a, so it's going to reflect down, 3 right, and I'm not moving up, I'm not moving down, because there's no constant there. Here, there's no linear term, so it's not in vertex form. This is reflecting down. It's stretched by 2, so you see it got really slim and narrow. And it went up 3, so it's up at the 3, and then it's all going down. So this is like a Slim Jim going down. Now I have this in vertex form, so I have reflection down. A lot of these are negative. Interesting. Now I have a fraction as the a, so that's going to be compressed and fat. See, this is like fat compared to this is like fat and short. And then I am going right 5, so that's where it is moving horizontally. And then last but not least, I have this. Looks like this is the parent function, and I'm just adding 1. If you ever see like a parent function and you're adding or subtracting something, just know that that's just moving up or down. It's going to look just like the parent, just a little higher or a little lower. So it's just up 1. Okay, that's transformations for you. Factoring. So when trinomials, I don't know why I started with this. I should have started with GCF, but that's okay. When a is 1, so these are the basic product sum game. So make sure it's in standard form. Do the product sum game, find your factors, set to 0, and solve them. And then you're going to list it as a set. So remember those braces. These are called braces. And these are the x values, right, that would make the equation true if y were 0. Here's my example. Here I have a very basic trinomial x squared minus 9x minus 36. And I found the 2 factors, negative 12 and 3, put them in the right binomial form, set both sides to 0. And I got my set negative 3 and 12. Over here, when you have an a that's larger than 1, if you can't factor out that a value, then you have to do that slide and divide. This is probably my least favorite, but that's okay. But make sure it's in standard form. You're going to multiply the a by the c like we did here to get a new c value that I can then factor. So then I'm going to factor out, found the 2 factors of this new equation. I got a positive 6 and negative 5. Then remember I have to return the 2, right? I have to return what I multiplied by dividing it, the opposite operation. So divide it out and then simplify. So 6 divided by 2 is 3. So that's as simplified as it gets. 5 over 2, I can't really simplify it anymore, so you would move. Here, I'll even do the 2 in front of the x, minus 5. Set both equal to 0, and I get my new set, which is negative 3 and 5 halves. So that's the slide and divide. Now I have my personal favorite. I don't know what you guys are deciding on yours, but for your slideshow. But so greatest common factor. So identify if you have something like this. A lot of times you'll see it in this form where you can factor out an x and maybe a 2, right? So you 2 and x goes into both 16x squared and 10x, right? I'm going to divide it out, put it aside, then divide. So put aside the greatest common factor, divide. So this is the quotient when I divide both terms, end up with this. Now I can easily set both sides to equal to 0, so 2x equals 0 and 8x minus 5 equals 0. And then I can solve to get my 2 solutions here. Remember, sometimes when you factor a number out, you may get something that you can factor again, like look for difference of squares, for example. Okay, here we have square roots. So I really like square roots too. Like if I see something like this, 4x squared equals 49, I see that they're both square numbers. Then I can just take the square of each, the square root of each. So I like that. And you can always divide out this 4 if it goes into both. Anyway, but then when you find the square roots, you have to remember it's going to be a positive and a negative solution because they're both square numbers and they're going to be the same because they're squares. Complete the square. This is probably one of my, I don't love doing complete the square, but I think it's very clever. Things to look for is if B is even, that's a good sign, okay? Sometimes if you have A is 1, it saves time, but you can still use this if A is greater than 1, but you just have to divide out the A because your goal is to get A, the coefficient of the x squared term, to be 1. And then rewrite it in that form with the C on the side, the constant on the right. Take half of B, square it, and add it to both sides. Factor, take the square root of both sides. So here is my example here of when I did it. Let's see, I factored out the 3 because it goes into all of these numbers. And I ended up with this instead. I took half of the B, the linear term, squared it, add it to both sides. I'll make it stand out here. And then I found this perfect square trinomial, which I could then easily factor and then take the square root. And same with this. So I had 2 perfect squares, which made it easy. Right, and then I could take the square root of 9, which I know is a positive and negative because I'm solving, not just simplifying. And I end up with 3 and 9. Okay. Factoring over here. Quadratic formula. Quadratic formula, you can always use it when the equation is not factorable. You just have to make sure it's in standard form. Sorry, my dog is going crazy. Oh, now my dog is scratching at the door. You have to put it in standard form. You're going to plug and play. So you're going to just use this formula. And you're going to plug in, you're going to identify your A, B, and C values here. Identify them and then simply plug in these numbers to your equation, which I did here. Make sure that you take your time with this discriminant here because it can be tricky when you're simplifying radicals, which is that was less than 12.5, right? You might end up with something like this, right? They're going to always be, well, I shouldn't say always. Many times, oftentimes you'll have two solutions, but remember, not always. Here, now I can show you that. So again, you can pause and see how I did this, okay? Word problems. Okay, so we have geometric applications, right? So if you have some kind of a rectangle and it's telling you to find out, it gives you the area, or maybe you have to find out the area, just make sure you identify your variables, right? Draw pictures. It always helps me. Anything geometric, I always draw pictures, and I am a visual person. Translate anything into mathese, I call it, and solve for the positive solution. So oftentimes you can't have a negative number as like a side, okay? So here was the information I got from one of the problems. If I know the area, here are the sides, I want to solve for x. So great, I know that when you find the area, you multiply the sides together, you get the area. I did that. I ended up finding, getting to a trinomial, factored it, got my solution, crossed off my negative solution, and I know x is 9. But be careful, sometimes it might ask, well, what is one of the sides? Like, maybe this is the length, right? And this is the width. So the answer wouldn't be 9. The answer would be 9 plus 3 would be 12, right? So you just have to read the question very carefully. Consecutive integer problems. Again, you have to read the instructions carefully. Define your variables. That's when you do the let x be, right? Draw pictures if you want to. Translate the words into mathese. Remember, product is always multiply, sum, add, is, always use equal sign. And then solve, okay? So if you have the product of 2 positive consecutive integers, remember an integer, right, is a whole number, right? Is 56. What are the numbers? So here is, I define my variables. Let x be the first number. X plus 1 is the second. So it's just 1 higher than x, the first one. Notice it doesn't say even or odd or anything. If it were even and odd, then you'd have to add 2 because they're 2 apart. Then if you're multiplying them, the product of 2 is equal sign 56. What are the numbers? So you have to distribute this out. You do wink and smile. You end up with a trinomial. You end up with 2 factors. And remember, we're looking for a positive. So anything that's negative, you can put an X through. And you end up with one number. The lower number is 7. Greater number is 8. We're almost done. Then we have projectile motion. Key things here is read the problem carefully. Underline what it's asking you to do. So a lot of times they're going to ask, well, what's the maximum height? And maybe how long does it take, right, to get back to the ground or the water or something like that, right? What's really trying to, if it's ground or the water, then it wants you to think of setting it to 0. Okay, so if a golf ball is kicked up at 90 feet per second, they will offer an equation, right? If the height equals this kind of basic quadratic expression, it's going to give the height after the t seconds. So the question might be, yeah, find the maximum height. So you're going to use that x equals negative b over 2a, but instead of x, you're going to use t. So that's going to be the time. So you're just going to plug in those values, right? Because I know my a is negative 16, my b is 90, right? So I'm just plugging it into that equation. I'm going to get an approximate time. And then what I do is I take that number and I plug it back into the equation. And because I want to solve my height. And I'm going to get something like that. Now, a second question might be how long till it gets to the ground. So whenever you see a question like that, take the original expression or equation and make sure it's set to 0. And for this case, I factored out the negative 2t. It's good to factor out a negative number so you end up with a positive in your binomial, just so you know. And then you're going to end up with your positive solution is the answer. Quadratic regression. Okay, so this will be one of the last questions you see. Read problem carefully, underline the question, study the table. So there is going to give you a table. Maybe it has an x and y value. Maybe it has like time and height value. Maybe it'll be like time and how much something is worth, right? So then you're going to create the table in Desmos, enter all the values, and then on that second line, you're going to enter that approximation because you're trying to find either a curve or a line of best fit. And it's trying to basically create the equation for you to get your ABC values. Then use that equation that it gives you. Plug in that number, whatever they're asking you to solve. Okay? So here's our example for that. So if you have an arrow shot, height and time table is below. Maybe it's asking you to find the height after 8 seconds. So I entered these numbers into Desmos. And notice I have like 8 is question mark. We don't know. That's what we're being asked to find. Desmos was very nice and gave me this equation. Once I get an equation, which is a curve of best fit, because curve is quadratic, then I'm going to plug in 8. After 8, right, seconds, what's my height? So I plug in 8, and then I end up with my height. So y equals 165 feet. So after 8 seconds, that's still really high, by the way. Wow, that's crazy. Okay, the end. I'm going to rock this test. I know you are too. Okay, good luck.